Hello learners, welcome to this session. This session is all about basics of blockchain technology, Unit 4, MIO 002, Smart Technologies. So there is a much hype nowadays regarding the blockchain technology. In this session, let us study what is blockchain technology, what are its characteristics, how it works, what are the benefits of blockchain technology, and some illustrations. The whole point of using a blockchain is to let people, in particular people who don't trust one another, share valuable data in a secure, tamper-proof way. So this was the quote given by MIT Technology Review. So this is all about the trust, and it follows a kind of approach called as DLT approach. So blockchain, which is also referred as distributed ledger technology, in short we call it as DLT, makes the history of any digital asset unalterable and transparent through the use of a decentralized network and cryptographic hashing. So DLT is a platform that uses ledgers stored on separate connected devices in a network to ensure data accuracy and security. Blockchain evolved from distributed ledger technology to address growing concerns that too many third parties are involved in too many transactions. You can always refer this DLT with the old physical ledgers, those were being followed in banks earlier. So what is the definition of a blockchain? Blockchain is a shared immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. An asset here can be a tangible, maybe a house, car, cash, land, or intangible like intellectual property, patents, copyrights, branding, etc. Virtually anything of value can be tracked and traded on a blockchain network, reducing risk and cutting costs for all involved. Here we can see a simple analogy for understanding the blockchain technology. This is not actually what happens with the Google Docs. However, you can compare this with a Google Sheet. Like this is meant for a simple analogy. When you create a Google Doc and share it with a group of people, the document is simply distributed instead of copied or transferred. This creates a decentralized distribution chain that gives everyone access to a base document at the same time. No one is locked out awaiting changes from another party, while all modifications to the document are being recorded in real time, making changes completely transparent. A significant gap to note, however, is that unlike Google Docs, original content and data on the blockchain cannot be modified once written, adding to its level of security. Of course, blockchain is more complicated than a Google Doc, but the analogy whatever we had seen is apt because it illustrates critical ideas of the technology. Let us see the evolution of blockchain technology. The first concept of blockchain dates back to 1991 when the idea of a cryptographically secured chain of records, or you can call them as blocks, was introduced by Stuart Haber and Wakefield Scott Stornetta. 2 decades later, the technology gained traction and widespread use. In the year 2008 marked a pivotal point for blockchain as Satoshi Nakamoto gave the technology an established model and planned application. The first blockchain and cryptocurrency officially launched in 2009, beginning the path of blockchain's impact across the tech sphere. Let us study the characteristics of a blockchain. A blockchain is a digital ledger where encrypted blocks of digital asset data are stored and chained together forming a chronological single source of truth for the data. Digital assets are distributed, not copied or transferred. Digital assets are decentralized, allowing for real-time accessibility, transparency and governance amongst more than one party. Blockchain ledgers are transparent. Any changes made are documented, preserving the integrity and the trust. Blockchain ledgers in public and constructed with inherent security measures, making it a prime technology for almost every sector. Why is this important? Business runs on information. The faster it's received and the more accurate it is, the better. Blockchain is an ideal for delivering that information because it provides immediate, shared and completely transparent information stored on an immutable ledger that can be accessed only by permissioned network members. A blockchain network can track orders, payments, accounts, production and much more. Because members share a single view of truth, you can see all details of a transaction end to end, giving you greater confidence as well as efficiency and opportunities. Let us study some key elements of blockchain technology. First one is distributed ledger technology. All network participants have access to distributed ledger and its immutable record of transactions. With this shared ledger, transactions are recorded only once, eliminating the duplication of effort that is typically of traditional business networks. So here you had heard a word called as immutable records. What are immutable records? No participant can change or tamper with a transaction after it is been recorded to the shared ledger. If a transaction record includes an error, a new transaction must be added to reverse the error and both transactions are then visible. So most of them, they use the smart contracts using the blockchain technology. So to speed the transactions, a set of rules called a smart contract is stored on the blockchain and executed automatically. A smart contract can define conditions for corporate bond transfers, include terms for travel insurance to be paid and much more. So we had listened about the various key components. Let us see how this blockchain works. As each transaction occurs, it is recorded as a block of data. Those transactions show the movement of an asset that can be tangible or intangible. The data block can record the information of your choice like who, what, when, where, how much and even the condition such as the temperature of a food shipment. Next one is each block is connected to the ones before and after it. So these blocks form a chain of data as an asset moves from place to place or ownership changes hands. The blocks confirm the exact time and sequence of transactions and the blocks link securely together to prevent any block from being altered or block being inserted between two existing blocks. Third is transactions are blocked together in an irreversible chain called as a blockchain. Each additional block strengthens the verification of the previous block and hence the entire blockchain. This renders the blockchain tamper evident, delivering the key strength of immutability. This removes the possibility of tampering by a malicious actor and builds a ledger of transactions you and other network members can trust. This is a simple illustration wherein which how the smart contracts work. Here one person, he wants to sell the house and then the other person wants to buy the house. So in order to eliminate all the intermediaries over here, these two persons come into a contract called as the smart contract. So the match buyer with seller exchange, then the contract receives the assets, contract distributes the assets. You can see here after clearing the and settlement and is automated. Here you can see the digitize the land deed, digitization of the currency like cryptocurrency may be used in order to do the transactions. So here both the parties are coming to a kind of smart contract wherein which one person is selling the house and the other person is involved in buying that house. Automatically the contract, the person whoever is selling the house will receive the assets or else the cash, and whoever is buying the house receives the documents called as the registration documents. So technically how this blockchain works, for proof of work normally called as POW blockchains, this technology consists of three major components. One is the blocks, second is the nodes, and third is the miners. So these are the three important attributes which constitute a blockchain to work. So what exactly is a block? Every chain consists of a multiple blocks, and each block has three elements. One is it stores the data in the block, the second is the nonce, or else you can call it as number used only once. Nonce in blockchain is a whole number that's randomly generated when a block is created, which then generates a block header hash. And then the third component is the hash itself. A hash in blockchain is a number permanently attached to the nonce. For Bitcoin hashes, these values must start with a huge number of zeros, be extremely small. Second one is when the first block of a chain is created, a nonce generates the cryptographic hash. The data in the block is considered signed and forever tied to the nonce and hash unless it is mined. What is a miner in a blockchain? A miner creates new blocks on the chain through a process called mining. In a blockchain, every block has its own unique nonce and hash, but also references the hash of the previous block in the chain. So mining a block isn't easy, especially on large chains. Miners use special software to solve the incredibly complex math problem of finding a nonce that generates an accepted hash. Because the nonce is only 32 bits and the hash is 256 bits, there are roughly 4 billion possible nonce hash combinations that must be mined before the right one is found. When that happens, miners are said to have found the golden nonce and their block is added to the chain. Making a change to any block earlier in the chain requires remining not just the block with the change, but all the blocks that come after. This is why it's extremely difficult to manipulate blockchain technology. Think of it as safety in math, since finding golden nonces requires an enormous amount of time and computing power. When a block is successfully mined, the change is accepted by all of the nodes on the network and the miner is rewarded financially. So we call blockchain as a decentralization aspect. So what is decentralization in a blockchain? One of the most important aspects in blockchain technology is the decentralization aspect. No one computer or organization can own the whole chain. Instead, it is distributed ledger via the nodes connected to the chain. So all of the nodes will be the participatory nodes. Blockchain nodes can be any kind of electronic device that maintains copies of the chain and keeps the network functioning. It may be a computer, it may be a mobile, or else it may be a tab also in some cases. Every node has its own copy of the blockchain and the network must algorithmically approve any newly mined block for the chain to be updated, trusted and verified. Since blockchains are transparent, every action in the ledger can easily checked and viewed, creating inherent blockchain security. Each participant is given a unique alphanumeric identification number that shows their transactions. Combining public information with a system of checks and balances helps the blockchain maintain integrity and creates trust among the users. Essentially, blockchains can be thought of as the scalability of trust via technology. Here we can see a simple illustration. So the thing that is being highlighted is called as a block, wherein which it constitutes three main components. One is the data component, second is the hash, and third is the hash of the previous block. For example, in a Bitcoin blockchain, a data is, you can see here, it is being illustrated from to and the amount that is need to be transferred. So this is a simple example of a Bitcoin block. And hash is nothing but it is an alphanumeric number. You can represent it as a continuous digits. This is the second component that it would have. This is the second component that the block should have, and the third component is hash of the previous block. So, whatever the number that is being attached with the earlier box hash, that would be stored here in order to get a chain of blocks. So, here the third component is the hash of previous block. You can see that the green color, suppose if it is a first block, we call it as a genesis block, and here there is no block attached earlier. So, this is the genesis block, and the hash of previous block will be 0000. However, for the yellow block, so the green block's hash will be noted as the hash of previous blocks. Obviously, it also will have its own hash. Like for the red one, the yellow hash of previous block will be attached over here, and it will be having its own hash also. So, this is how the completely with the three aspects the blockchain will be continued. So, this is an example. You can see the hash is written over here and the previous hash is also written over here. Hash for the first block is 1Z8F for example, and the previous hash is 000. Why? Because this is the genesis block and it does not carry the previous hash. Likewise, you can see the second block hash and the previous hash. Here the previous hash is being recorded as 1Z8F, which is actually the hash of the first block. Likewise, for the 3, the previous hash is 6BQ1, which exactly is the hash of the yellow block. So, in this way the hash and the previous hashes are being recorded on the blocks. So, this is an illustration wherein which you can see the marked hash and the previous hashes are being shown on the slide. So, this is the genesis block. The first block which has the previous hash 0000 is the genesis block, or you can call it as the start block, and second yellow block is the second block and red block is the third block. So, if it is got tampered, so you can see here it can't happen. However, it can't rewrite the hash or the previous hashes. However, if it got tampered, it will be visible for the other parties whoever are participating in that particular blockchain. This is a proof of work wherein which it takes some 10 minutes or 15 minutes and it will be consuming a huge computing power in order to generate the hash and other things. So, this particular blockchain is a peer-to-peer network, and these are all, suppose if there are 6 participants, everybody will be sitting on their nodes and then they will be having the record of each and every blockchain on their nodes. All of them receives the whole block copy of the blockchain. You can see here, first person whoever is participating in the P2P network of blockchain, he will be having his own record. Likewise, the same records will be possessed by the other participants also on their nodes. So, if at all a new block is to be created, this is the case, use case. So, then it should be verified by each and every participants. If at all it is been verified by each and every participant, then only it will be added to the blockchain. So, consensus if the block is not tampered with, then if at all it is being verified, the block will be added to the blockchain. So, let us see the benefits of blockchain. We had talked much about the blockchain and then how it works. Let us see the benefits. First benefit here we have to talk about is the greater trust. With blockchain as a member of members only network, you can rest assured that you are receiving accurate and timely data and that your confidential blockchain records will be shared only with the network members to whom you have specially granted the access. So, in the P2P network, only the participants will receive the exact blockchain copy, whatever that is, evenly distributed. Next benefit is the greater security. Consensus on data accuracy is required from all network members, and all validated transactions are immutable because they are recorded permanently. No one, not even a system administrator, can delete the transaction. Next benefit is the more efficiency. With a distributed ledger that is shared among members of a network, time wasting record reconciliations are eliminated. And to speed transactions, a set of rules called a smart contract can be stored on the blockchain and executed automatically. Let us learn the types of blockchain networks. It is not a single type of blockchain network. However, you have four types of networks. One is the public blockchain, second is the private blockchain, third is the permissioned blockchain, and fourth is the built by consortium blockchain. Public blockchain networks is one that anyone can join and participate in, just like a Bitcoin blockchain. Drawbacks might include substantial computational power required, little or no privacy of transactions, and may be weak in the security aspects. These are important considerations for enterprise use cases of blockchain. Then comes the second type of blockchain network, that is the private blockchain network. A private blockchain network similar to a public blockchain network is a decentralized peer-to-peer network. However, one organization governs the network, controlling who is allowed to participate, execute a consensus protocol, and maintain the shared ledger. Depending on the use case, this can significantly boost trust and confidence between the participants. A private blockchain can be run behind a corporate firewall and even be hosted on premises. The third type of network is the permissioned blockchain networks. Businesses who set up a private blockchain will generally set up a permissioned blockchain network. It is important to note that public blockchain networks can also be permissioned. This places restrictions on who is allowed to participate in the network and in what transactions. Participants need to obtain an invitation or permission to join for the permission blockchain networks. The fourth and the final type is the consortium blockchains. Multiple organizations can share the responsibilities of maintaining a blockchain. These pre-selected organizations determine who may submit transactions or access the data. Consortium blockchain is ideal for business when all participants need to be permissioned and have a shared responsibility for the blockchain. So there are various applications for each and every domain. The domains may be a supply chain management, healthcare domain, government sector, retail business, media and advertising, oil and gas industries, telecommunication industries, manufacturing companies, insurance companies, financial services companies, travel and transportation. For all such kind of domains, you can visualize many blockchain applications. First of all, the simple thing that you can understand is a simple smart contract between two companies. So that will be like a very good use case for each and every domain that we had spelled out. So before winding up this particular session, let us sum up what we had studied in this session. The blockchain is a digital database composed of encrypted blocks of data which are chained together and secured by complex math problems. The math problems involving matching nonces and hashes is almost impossible to change later. The record of previous actions on the blockchain is highly accurate and secure from manipulation. The blockchain is distributed identically across different decentralized nodes, ensuring no one organization can own or manipulate it. Here in this session, we had studied the definition of the DLT, that is the distributed ledger technology, wherein which the complete base of blockchain technology is being hired from the DLT. Here we have seen the characteristics, how the blockchain works, and then what kind of blockchains are there, what types of blockchains are there, are the major things that we had listened to in this particular session. I finished the session over here. Wish you all the best.